CI project, about OpenStack, and about all the effort that took to get OpenStack running smoothly on the developer cloud, if we can say we're running smoothly. The talk today is going to be like a walkthrough from where we started with packages that were broken and trying to install OpenStack from there to where we are today, where we have a cloud that is working, fully functional, and that we can give projects to people from. We will be talking about what building OpenStack means. We'll be talking about what the upstream work we've been doing. And we're also going to be talking about the developer cloud itself and how it evolved from version 1 that we had last year to version 2 that we have now in Cambridge. I will be talking also slightly about interoperability because that's like the last step to get the cloud up there comparable to all the other clouds that are right now installed in production. So that will be like closing the circle and closing what deploying OpenStack in production means for Aarch64. You won't be hearing everything from me. You will be hearing this from the team that has been working on that. We will have Yibo and Jack from ARM that have been collaborating with Linaro on this project. We will have Marcin talking about building stuff. And we will have Andy as well from the systems team at Linaro that has been running the cloud for a while. First, I wanted to do like a brief overview of what OpenStack is for those people that have never worked with it. OpenStack is no more than a collection of services running on your servers, all of them together, right? We have Nova that gives you compute. We have Ironic, which helps you deploy the machines. We have Keystone, which helps you authenticate, networking, Neutron. We have Glance for images. And we also have a set of Ansible scripts that allow you to deploy the whole thing. There is Heat, which we haven't fully tested yet, but that will probably be ready in another 2 to 3 weeks. And then for the backend, for storage, we're using Ceph, which is also, I'm glad to report, fully working. All right, so I will let Marcin, our system integrator, talk about what building OpenStack is.
Hello. Basically, when I joined Linaro for second time, I got handled that, okay, you will be working on OpenStack. I had no idea what OpenStack is, not that I have more about now, but it's much better. So we decided that we will support 2 distributions, Debian Jessie and CentOS 7. And as Debian had a team working on OpenStack, and they decided that they will provide us packages if we provide them machine. So we provided them machine, and we got packages from them. I took care of CentOS 7 packages. For CentOS, when it comes to OpenStack, there is a group of guys called LDO project, and they have fully operational OpenStack version Mitaka, which was the latest at that moment. So I took their source packages, I rebuilt everything on ARM v8, and then we started discussions on, guys, you need to merge those set of fixes from Fedora to your components to get everything working. It took a bit, but things got sorted out, merged, and Linaro now provides set of packages for CentOS 7 for those who want to run OpenStack. I have to admit it works, but there are some issues with networking. That's why we moved to Newton with our development. Newton was at that time in the developer phase. It was just recently released into open, and we decided that for Newton we will go not for packaging, because there was no packages when we started working on Newton, but to go for providing tarballs with each component. Tarballs contain Python virtual env environment with everything needed to get each component working separate from the other. And we use Ansible to deploy those and to install whatever is needed from Debian packages. Developer Cloud in Cambridge, the one where we have Newton now, is fully on Debian Jessie, and the work on packaging stuff for Debian is ongoing. And there are some packages available, I think. And for CentOS, it just starts. But the good thing is that compared to the previous OpenStack releases at CentOS, the Newton one will be built at the same time as x86 one. So if you are running CentOS, in a few weeks' time, thanks to Jim, Perrin, and guys from RDO, you could deploy OpenStack on CentOS on Aarch64 machines. And to get things running, we were working also on images. The Zeros image is the very minimal image used by OpenStack community for testing and for checking, is everything working at all? I spent, I think, something like 2-3 weeks on updating their build system and merging stuff, so we can now run Zeros images on ARMv8 using UEFI booting, etc. And the work was merged, and soon there should be 0.4 release of Zeros, which will contain all our work. This link on the slide goes to daily image, which we tested, and it's fully working. As Linaro, we provide also Debian Jessie and CentOS 7 images. They are different than images provided by distributions because we are using our Linaro overlay with updates for things like libvirt, for example, and we are also using Linaro kernels in those images. We discussed with Fedora, CentOS, and CoreOS communities, and we will have their images in our cloud soon. Though for some of them, there will be just automatic without any work from our side other than here you have the access, and images will be uploaded at the same time as to many other cloud providers. And I would like to give the time for Jack. Jack will tell about how our upstreaming works.
So I would like to try to introduce what ARM team done with collaboration with Linaro in the upstream, works of OpenStack. And so next slide. The first module is Nova. So for Nova, we did 2 jobs. One is for the enablement of the main features of Nova on Aarch64. Almost all the features are enabled on Aarch64, except for some hot plug issue, which still has some, small error. When we use this attach such kind of device, there is still some error. Except for this, all the features are enabled on Aarch64. And the second thing we've done is the Nova Tempest. So as you know, the Tempest is the standard of the OpenStack community CI, in terms of unit tests. So to make Nova accepted by the community of OpenStack, we need to pass the Tempest tests. So almost all the Tempest tests are now passed. As you know, again, we fixed some issues that, the failed cases, we fixed them. So Here is a table of the features which we are enabled on Aarch64. You can see that the basic features such as launch instance or stop an instance, or such like save some snapshot, and especially the live migration, these features are all enabled on Aarch64. So next page. This page is about the new trend enablement on Aarch64 that we done for the passing year. So again, this is also divided into two jobs. One is the feature enablement. Another is the Tempest tests. So for feature enablements, the core service, for the agents are all validated on Aarch64. And also for the Open Daylight plugin, it is also validated. But for the Open Switch plus DPDK, for this one, is still in progress. And for the neutron Tempest part, as you can see that for this picture, the green blocks are all enabled. And for the white blocks, they are still ongoing. So as we can see from this picture, most of the features are enabled, on Neutron. So next. So this page is about the self-integration with OpenStack we've done for, And first is the RBD and the OSD features. This one is about the pure self-enablement on Aarch64. Both of them are already done. And the next two ones, the self-RBD integration with OpenStack and the self-OSD integration with OpenStack. For the first one, the RBD integration with OpenStack, for this feature is 100% done. And we use Ceph as a single backend to provide volume services, like attach or something. And for the OS integration with OpenStack, here most features are validated, but some of the features is still ongoing. So for the last point is about the self-performance testing. For this one, it's still ongoing because, as you know, there's many self-cluster performance test cases needs to be carried out. And also, we need to compare the performance with x86. So, okay, for next part, we will introduce some detail of the patches we've poured into the upstream. So I will let Yibo to present this part.
Hello, I'm to introduce some of the patches for Aarch64 to running OpenStacks to make it run smoothly on ARM servers. The ARM workloads team starts this job at about end of April this year. So at the very beginning, when we first tried to launch an instance on ARM servers, we found it failed. It cannot work. So which means the basic functions of OpenStack doesn't work on Aarch64. So we tried to debug the code and find what's the reason of this. And so this is the first patch we delivered to the OpenStack community, which enables Nova functions, Nova basic functions on ARM servers. We found the reason why virtual machines, when Nova tries to create virtual machines, it is through the libvirt API to create KVM virtual machines, but the Nova code is developed and tested only on x86 platforms, so the virtual machine configurations just don't work on Aarch64. For example, the default disk controller is hard-coded to IDE devices. So IDE is a legacy standard. It's not supported on new platforms like Aarch64. So the virtual machine just doesn't work. It cannot be launched. So we changed the default devices, default disk controllers to SCSI, and it works on Aarch64. So this is the first patch, and after applying this patch, the basic functions of Nova works. Another patch I want to introduce is about the Ironic. So Ironic, to support a multi-architecture deployment of Ironic services. So Ironic is a bare metal provisioning service of OpenStack. So for example, if you have already set up OpenStack cloudings, but you want to expand its capability, you buy some new servers and want to deploy these servers as a computer node or networking node. So normally you need to install operating systems to install services and then configure the services. So this is very tedious jobs. So what Ironic does is to deploy all these services, all the bare metal machines automatically. So Ironic is also a OpenStack service, so which means you can use OpenStack to deploy OpenStack. This is very convenient. But there's one missing things in current implementations, that the Ironic services current code can only deploy x86 servers. So if you want to use Ironic to deploy other architectures such as Aarch64, you need to change the configurations and restart the service. But after you change these configurations, this Ironic service can only deploy Aarch64 nodes. So this is very inflexible. So we propose this patch to the community to support general solutions. So you can use Ironic to deploy a hybrid, to deploy a clouding with hybrid architectures. So for example, it makes sense to build a clouding with x86 computer nodes and use Aarch64 as the storage nodes. This makes sense. But if you use the old code of Ironic, this is some problems because you need to change configurations to deploy them one by one, so this is not good. So this patch is for this purpose. About this patch is a new feature to the Ironic community, so it costs a very long time, so it's still under reviewing. So in fact, this reflects difficulties that we are facing when doing upstreams, because the community are still not very familiar with the Aarch64 architectures. So most of the code and most of their implementations are still based on the x86 servers. For example, the CIs are only for x86, so the developers or even some of the maintainers just wonders why we need these new features. What can it brings do good to the current OpenStack community? So this is something because they don't have Aarch64 servers, so they still cannot validate if our code does works. So this is one difficulty we are facing when doing upstreams for Aarch64. But things are now changing. So the acceptance of the OpenStack community for Aarch64 servers are now going up. So we are glad to see these changes. Another patch I want to introduce is the last one about Ceph. So because we are using Ceph as the back end of our storage service, object storage or block storage, or use Ceph as the back end. So we do some optimizations for the self storages. This patch is about to optimize the self hash algorithms because every hash objects are hashed. So for quick lookups, but the hashing algorithms we found the code is not very good. So we just changed some of the code and changed the code and verified on both x86 and on Aarch64s. And we found that after optimization, the performance gain on Aarch64 is good. It's about 20% performance gains. So we proposed this patch, and it's already merged. Besides this list, there are many more other patches for Aarch64, and not listed here. So, for example, for networking ODLs, this is the OpenStack, Open Daylight plugin for Neutron, and Oslo, which is a common module for OpenStack. Next, I want to introduce a brief introduction of how we set up our test environment and how we verify that our do development and do upstreams. So the left part is, so basically we are using DevStack to deploy and to development OpenStack because DevStack is a standard way for to do this kind of job. It's very convenient. You just create a configuration file and stack.sh, just wait for it. Wait for it works. And so most of the time, for convenience, we deploy all our service in one host, so all in one deployment. But for some real life cases, we will also deploy different service in different nodes. So to set up a multi-host development environment to verify that everything just works in real life and in all cases. So this is the OpenStack enablement patches and the test environment we are using for this purpose. Okay, next Andy to introduce the developer cloud.
So the first developer cloud that we set up was based in a lab that we have in Austin, and the early work was kind of done by some, I guess I'd call them trailblazers in LEG. The main guys were probably Andrew McDermott and Michael Hudson and Clark Laughlin, and they basically spent a lot of time just figuring out how can we run OpenStack on Aarch64. And they got that to a pretty decent place, and then I think probably around last December or so, Yazin got tasked with actually deploying this on several servers within our colo and trying to set something up where we could put users on it. And what we've got deployed right now there is kind of what I guess you simplify it as calling it kind of a private cloud. So we've got OpenStack deployed within our labs network, and we manage VMs for users on their behalf. And it's worked well for us so far, and we actually have a lot of important projects that have taken advantage of this and have been able to port features to ARM for us. But with this experience, we kind of sat around a few months ago and we're like, we need to do something better, and we've come up with this kind of idea, what we called our V2 cloud. This cloud's a lot more sophisticated than the older one, so we needed to work on Newton, and you have heard in the previous slides all these kind of features that we were working on upstreaming. So for my job, I was kind of chasing a moving target for several months. Newton was under development, so I kind of focused on, at least up front, figuring out how to automate this to where I could tear it down quickly, do a complete redeployment, or just do a small update. So my team is a systems team. We tend to manage everything with Ansible within Linaro, so we used Ansible for this. And we came up with a pretty good process to be able to, iterate on this and get something working. Marcin was saying earlier, part of this, since we didn't really have packages at the time, I used Python virtual environments and kind of make tarballs of these. It actually works kind of nice even in a production environment, because each one of these it's almost like a super simplified container or chroot, so I can just put Nova down and it's not going to step on Neutron or whatnot. And all that work has culminated in a cloud that we now have in Cambridge. And this is a real cloud. I mean, this is what you would expect from OpenStack, where there's a user interface provided by Horizon where you can log in and manage your own VMs. You can manage your own private networking. We're using Open vSwitch to manage our internal, what we call tenant networks. You can also access this now through like the classic OpenStack CLIs from your personal laptop, talking through public APIs. And the features of this are really kind of handy now with like something like Ceph and all these APIs. It works good for both ends. So from the user, it's easy for you to use and do what you want now. You don't have to come to me to ask me to reboot your VM or something. But for the management side of things, we have nice features now with say Ceph as our backend. I can actually migrate a VM, like a live migration, so you don't notice this, and I can put you on another host, and then we can just take that host offline and do some kind of upgrade, add a hard disk or whatever, and your VM keeps running, and with Ceph and all the redundant storage, everything just stays running, so we can iterate really quickly, and no one has to notice. We're like, now with what I have in Austin, every now and then I have to politely figure out who's all on one system and send them an email, and hey, do you guys mind if I take you offline on Saturday for an hour? We kind of talked about this big, amazing cloud now. Here is an actual picture of it, which probably isn't quite as impressive as what the presentation was leading up to, but it's actually pretty neat. So we've got 10 Overdrive Rev A servers. We have 2 Rev Bs, and we've got a D02 that are running. These are the cases that we put them in. The Lava Lab guys have kind of put together a nice little 1U case for these. They're loaded up with a bunch of RAM and a bunch of hard disks. So the RAM helps for the Nova VMs that we're running, and the hard disks help for our Ceph cluster. And as you can see, there's a little bit of extra space in there, so there's more servers to come. And I'll hand this off to Gema to talk about our upcoming next steps.
So, as you can see, we've come a long way in a relatively short period of time, but this is just the beginning. So we have what I would call a small cloud compared to things out there running, and we can start giving projects to people so that they can start working on our cloud. However, we need to automate the user management so that Andy and I don't have to be there typing commands to be able to enable users to use the cloud. We also have to fix back to 4.6.2, and I put this back here because this is the bug that will enable us to actually do hot plugging of volumes to our cloud so that everyone can follow that. And we're also going to test for interoperability on this cloud so that we're sure that a workload that can run on an x86 cloud, X cloud, Y cloud, because not all x86 clouds are the same, can also run on our cloud, and it will be seamless for the end user. So the end user doesn't really need to know that they're running on an Aarch64 cloud, right? We're also going to do a full run of upstream test suite just to make sure that we're not missing anything on this cloud before it goes to production. And we do need to finish the documentation of the reference architecture, which I'm going to talk about next. Then I will consider this cloud production ready, and we will be able to start giving tenants to people so that they can start working on it. This is the reference architecture. So this is what the software layout looks like in our cloud today. We have an entry router. You know, anyone from the internet would go through this entry router, and they would get access to their tenant's private network where their VMs will sit. We have one server that we call the API controller, which has all the API services deployed. We have a data controller, which has Rabbit and MySQL on it. And we do have all the networking services on the network controller. And then we have the compute nodes, right, where the VMs live and where all the storage is installed. As you can see, Ceph is distributed across all those nodes. So we have some monitors, we have some OSDs, and the whole thing seems to be holding up pretty nicely. So I'm quite happy with that. This reference architecture is what you will be able to deploy if you go and use our Ansible for deploying your cloud. You will need to choose, or you will be able to choose in the future where you want to put your services. And we need to do some work as well in being able to scale this. So we need to do a lot of testing around being able to scale each of the services so that you can have clusters of things. Now I will take my Linaro hat off and put on my DevCore hat, right? Interoperability. So as part of the DevCore committee or the Interop working group, because we changed our name like 2 weeks ago, we've been working on making sure that users of clouds can actually run their workloads seamlessly on different clouds. So we have out there people that are using clouds that want to provide their services on different OpenStack clouds. So how do you make sure that those people do not carry an overhead of difference in APIs on the different clouds, right? That's what DevCore or Interop working group is trying to make sure doesn't happen. So we want to make sure that when someone runs a workload on an OpenStack cloud, they get the same experience no matter what the provider is. And the RevStack project is the enabler for being able to run all those tests. So if you want to go and check what this project is about, you will see what the features we include and what APIs we're actually interested in. This keeps growing over time. So basically what we're going to do, if we consider all those clouds x86 except for D, so D will be our cloud, we want to make sure that this workload that this user is running is going to be seamlessly run on all of them. And we will present the findings of this testing at ODS in 3 weeks. So watch out for that. Here are some links and references to everything we've talked about. And I think this closes our presentation. So I wonder if anyone has any questions that we could address, because I think we have time for that. Maybe. Let me find out.
Questions, or are you just so in awe? Any? They covered, that team covered a lot of things, right? Everything from working upstream, reference cloud, how we're building things. Any burning questions? What's that? Okay.
Regarding the hot plug, what component you guys are looking at? So is like a I/O side PCI? Right now you use VirtIO, MMIO. It's not supporting hot plug, and also memory and CPU. And Red Hat is proposing to use VirtIO PCI for all the MacBook device for the gas VM. So if that's a problem, so maybe you guys can help with the discussion at the QEMU community. So
I'm not sure I understand the question.
So what I mean is what kind of hot plug component? There was a slide talking about you guys have issue with hot plug.
Ah, yeah.
Yeah. So which component you have problem with?
We believe that the problem we have is that we're trying to use a packaged version of libvirt that is on Debian that is not the same as the one that's currently on Ubuntu. So I do believe that the problem we have is with packaging, but we're still investigating. If you want to go to that back and read through that, you will find all our findings, so all our testing is described there, and maybe we could talk about this later and try to figure out if you can help us solve that.
Okay.
Because there might be some hack on some of the packages that are published out there in the different distros, and that's why we're seeing this difference.
Okay, so the second thing regarding the libvirt, the upstream version, we have fixed a lot of issues you guys mentioned. So I don't know which version you guys
We
were
are running
using.
version 2.2.0.
Okay.
And we have that one on the Linaro overlay. So we were trying to deploy with 2.1.0, but we had a problem that was kind of unsurmountable, so we upgraded it to 2.2.0, and we're up and running nicely.
Okay. Yeah, because the serial console issue, we have seen that, and also SCSI issue, we resolved that. And going forward, we fix, for example, gig v3, those has been upstream to the libvirt. So maybe you guys can try that and see if that helps.
I definitely want to talk to you more after this session, and we need to connect and make sure that we're in sync so that we don't miss any great features that you're putting out there, and we have them tested. So one of the next steps for this project is to set up some CI for the reference architecture, right? I want to make sure that when something changes on the full stack, we have it covered and we test it, and all the functionalities is still working fine.
Okay.
And that is, obviously, libvirt is a big part of that. Anything changes in libvirt, I want to test that our reference architecture still holds up with that.
All right.
Anybody else, any other questions?
No? Over there, Martin? John has a question.
Just a quick observation that bug 2462 seems to be a problem with AppArmor configuration. It looks like it's just a permission error from your AppArmor config. So maybe if someone here is an expert in AppArmor, I only know SE Linux, but if someone knows AppArmor, then that's probably what that bug is.
Yeah, that's why I put the bug there, because I was hoping that someone will open it and go, ah.
There you go. That's what I think the problem is. Someone here who knows AppArmor rules, you want to go and take a look and update them, because I think they're not.
We will do that. Okay, thank you.
All right.
Any other question or helping hand? Yep.
I might have missed some details during the presentation when you talked about multi-arch deployment. And I'm wondering whether this is involved at all in the cloud interoperability that you mentioned.
It is. And it is important because depending on the compute nodes architecture, you can run one image or another. But I've been having conversations this week about running x86 images on our cloud with the CoreOS upstream developer that I was talking to yesterday. So this is an avenue I would like to explore. So I would like to make sure, obviously you won't have the hardware virtualization help, so the images will be probably slower, but we could still potentially run x86 images on Aarch64 servers, but we haven't tested that yet, I don't think. Yibo, have you guys tested that?
Probably on V7 images would be nice.
Okay, you want to talk? Come up here.
From when it comes to market architecture, I think that one of the things which not yet tested but would be nice to test would be to run on V7 images, Guest images, because sometimes it's like if you have something which blocks you and all you have is machine with 2 gigs of memory, having cloud with V7 and 10 gigs of RAM can sometimes help.
Okay, so we'll add it to the to-do, right? All right. Does that answer your question?
Yep, thanks.
All right, thank you. Any more questions over here?
So how many users have you had coming through the developer cloud so far?
How many users?
Oh, I can answer that. We have far. All right, maybe you guys can hear me. We've had almost 400 requests for access, about 100, close to 100 users who've come on and off, and we're just flat out of hardware, right? So The thing we're begging right now is if you have some spare hardware, let us know because we could throw it into that and get that up and running. But requests now, I think we've just approached 400. It's interesting in that if you look at the breakdown geographically, it's 30% Asia, 30% Europe, 30% North America. I mean, it breaks out really nicely. 15 to 20% is academia. Open source projects is probably about 30%, and the rest are all commercial companies that have a software business. It's pretty interesting. Do you have any observations for like the demographics or user pool or anything like that? Yeah. That help?
So we would be delighted if anyone would help us fill that rack with more servers, right? The more CPU they have, the better. So we can add the hard drives, that's not a problem, and the memory. Any more questions? All right. Thank you very much, everyone, for your time, and find us and talk to us if you want.